we can still have a lot of practice, do you agree?
Yes.
And we have to practice a lot more of them. Two-way contingency tables is a new word for you, but it actually just means everything's put inside of a table. It's two ways because you can read it this way or this way. And what does it mean? Now, in your textbook, it was filled in, but you can also go and fill it in. When I talk about two events, A and B, and this is not A and this is not B, then you'll be able to go figure out what the totals are, wouldn't you? Because then it means that for A, it's 1 plus 3 giving me, right? And 12 and 36 giving me?
48.
And the same thing downwards. That's why it's called a two-way contingency table. So it works that way and it works this way as well. So downwards, this would be 13 and this would be 39. And both of them have to add up to the same thing. Otherwise, you're not doing it right. So I could have in an exam said, find this one for a mark. And that's easy peasy marks. Okay, but then reading from the contingency table to get my probabilities. For instance, I'll ask you, find me the probability of A. I don't even know what A and B are. Irrelevant. Doesn't matter if you know whether it's people that take accounting, people that go for a holiday at the coast, or doesn't matter what the situation was. What would you say would be the probability of A? Thinking about this table. What is A? Right? So that would mean 4. What is the other stuff about? Are these two both A? Yeah. It's A and B. And this is A, but not B. But they're still both A. So if I'm asking you for the probability of A, that doesn't matter if it's B or not B, and it doesn't matter what the story is, it'll then be 4 out of
52.
52. That's the whole big spectrum. If you had been in a Venn diagram, 52 would have been your sample space. Are you with me? So what would be probability of B?
So it would be
13 out of 52 guys. And if it can simplify, you'll do that, right? But for now, that's fine. Because that can definitely simplify. Probability of A and B. Now we're getting to where they intersect, right? But I'm not seeing a Venn diagram. That's the reason why we're doing this lesson, so that you can know how a table works. Where would be the probability of A and B taking place? So, 1. A and B would be. I'm actually teaching you to read a table here. Are you with me? So what would be A or B? Or is when you're in the Venn diagram and you add everything together, right?
yes.
So how do I add all this together? A or B. So that's A or B. So what does you add? 1 and the 12 and the 3. Just don't add that twice. Just like in the Venn diagrams. There's the B. Don't look at the totals for now. There's the B. There's the A. So or add them all together. Are you reading this? So it'll be 1 plus 3 plus 12 giving me out of 52, which you then can go and simplify. A or B. Right, now we're getting technical. A and not B. Same thing. Where's the A and where's the not B? And means where they intersect. There's A, there's not B. So where do they intersect? And 3. So we're getting this. Learning to read contingency tables. A or not B. What do? For all, you add them all together. Where's the A? Where's the not B? So what do you add? 1 and 3 and 36. Just don't add it twice. 1 and 3 and 36 gives me? Okay, especially now when you go back to this question, you would like to know where it comes from. So if you now say, simplify and divide 4 and divide whatever, you're not going to know where it came from if your answer was a quarter. This makes sense when you go look at it now. A, not A, and not B. What does A mean?
Your
They intersect.
intersection.
Where is not A? Not B.
36.
So they intersect at 36. Now it's easy, right? And then we simplify. Now for A and B, the question is, are they mutually exclusive, and give me a reason.
Yeah.
No, you've got a mark, but why? Well, how do I know if they intersect?
Oh,
Because there is a yeah. But you've got to say something logical there. You're perfectly right, but how are we going to state this? So are they? No. Why? Because A and B is not equal to 0. If the A and the B part was 0, no chance of them both happening at the same time, then they're mutually exclusive. Then they don't cut. The plain English is they don't cut, they don't intersect, but how do I know that? Because there was a and that was not 0. There was an intersection. That was not equal to 0. There's various ways of writing that, and if all else fails, you speak it in English. Now, are they independent? So we're going back to stuff that we already know. Are they independent? How do I know if something is independent? I'm
you
testing.
calculate it. If you know the product.
What's the rule? The product, yeah,
Times PP.
must be the same as.
PA and PP.
So I don't put them equal when I'm trying to find independence. I put left hand side
And right hand side.
and right hand side, and then I check it out, and if they are equal, they are independent. If they're not, they're not. But now I'm using the contingency table. So the whole lesson is about how to use a contingency table. It's not new probability, it's just working with this contingency table. So what is the and? Do I have to go work this all out? Well,
No,
I've
we
got the
already
and.
got it. 152.
And then this would be the A that I've got,
And the
4 over 52, and the 13 over 52, and you'll have to give me an answer on a calculator, please, for that. Do I just time the 4 and the 13?
No.
You also have to time the 52s, right? This is multiplication, it's not adding. Answer, please. And I would bet your life on it, your life, not
1
mine.
over 52.
That's not going to be the same as this. Give it to me.
1 over 52.
Did you work it out?
Yes.
Okay. If it is equal, I was sure it wasn't going to be. If it is equal, what does it state?
Then therefore.
If this rule, because you're getting a mark for knowing that this is the rule you're checking out. If it's the same, then you say
Right hand side.
A and B are
Independent.
independent. And that is that for contingency tables. Done? You with me, guys? All it's about is if you're looking at it, you must know that this 36 is the intersection of not B and not A. And if you're looking at and, whichever one you're looking at, say it's A and the not B that you're looking at, A and the not B, then you just add them all together. That's it. They like to ask this question, just this question in contingency tables. They rather like to ask all of these inside of Venn diagrams, but anybody can change, and the habit of the past few years can change, so things can change. But normally this is what they ask in the contingency tables, knowing that you're going to go look for the PA and the PB, see if they are timed equal to the and part, and then say if it's, because if I never asked you for this, nothing. You had to know, I have to go and see if they are independent by looking at probability of just A, which was 4 out of 52, and just B, which is 13 out of 52. Are you with me?
Yes, ma'am.
They could have asked, what's the probability of not A? Just not A. Would have been 48 out of 52. Are you with me? And the probability of not B? 39. That wasn't asked in this particular question, but they could have. And then if I'm asking you whether they are dependent or independent or not independent, then you've got to go look for this formula and go know that you've got to do the PA on its own, PB on its own, multiply them, check out if the PA and B is the
Same.
That's it, contingency tables.